reactions. I apologize for the previous video. I was probably not very clear and efficient on what I was saying, and that's because my mic was actually acting up, because I did just get the new iPad, like I said. I had to re-edit all the volume settings and everything like that for the software I used to record this. But with that being said, I hope this is much more clear, and if it's not, please let me know. Wittig reactions are basically just copy and paste reactions. They're very simple, and I'll show you how they're done. And let's go on to see how they actually are done. So, first off, let's see how we actually set these up. The PPH3 basically just replaces the halogen. You're then going to get something that looks like this. This is your intermediate. This is positively charged, this is negatively charged, and then there is iodine out here, floating around with a negative charge also. Now when you react this with NBU lithium, you actually get what is used for the Wittig reaction, which is this bad boy right here. And now we can react that with ketones and aldehydes. And we can, oh shit, okay. Apologize for that. We can react this with ketones and aldehydes. Now, with that being said, how do these actually work? Well, you see, you're probably going to be given a molecule that looks like this with Dr. Paul. It's not going to actually have the double bond formed yet. So what you're going to have to do in your head is just put a double bond there, okay? It's not hard. If you see a positive and negative, just put a double bond there. Now, it's super duper simple. Cut, cut, paste here, and draw out your product, which is going to look like a house with a little antenna, like that. And ignore the other product because we don't really care about it. Now I do want to put some things, some notes. Like I said before, I just want you to be able to write these down. They react with aldehydes and ketones. They do not react with acid derivatives. Okay, so let's look at some examples. I'm going to pause the video real quick, let you guys solve these, and I'll go back and explain how they work. Okay, I'm back. I didn't actually go anywhere, but I'm back. Here we go. So, replace this with a double bond, like I said, first step. Slice, slice, replace, draw it, and that's your product. Pretty simple, huh? The next one. This one's a little more tricky because where are we going to add it? Are we going to add it here? Or are we going to add it here? Well, like I said previously, we do not want to add at acid derivatives. This is an acid derivative right here. This is technically an ester, which is an acid derivative. So we won't add there, we will add here. Now what's that going to look like? Well, once again, draw on your double bond because you're probably going to be given it like that. And then all you do is boom, boom, then paste. And then you get your final product, just like that. So, the next one. Let's look at this. First step, like I said, draw on your double bond. Because you're probably going to, like I always say, you're going to be given positive and minus. So just draw on your double bond. Cut, cut, paste, draw your product. Just like that. And that's how it works. Now do be careful because I won't explain. We'll go over that when we're in actual cyclization. But for these, this is how they work. And this would also be correct, I should note, if you draw your product like this. I don't like drawing it like that because it gets kind of confusing if you draw it like that. But that is technically correct. But as you can see, these are just copy and paste reactions. Nothing too hard. With that being said, have a wonderful night, and we're just going to keep going through some reactions.